Hello, this is a video that basically is going over chapter 9, and it's just a little review video. So if you want to kind of follow along, do some of the problems, pause the video, work them out, and then check with me as you're getting done. It's going to be a great review for your chapter 9 test. So I'm just pulling up a mid-chapter test. It's not anything that we've done. It's not anything that you have to do, but basically it goes over lesson 1s through 4, and then I'll do a few more problems over lessons 5 and 6. But um, this is a good little review because it's a mixture of everything we've learned so far, and so we can kind of do some of these problems. And I think the big thing is when we learn each individual lesson, we understand it and it's makes sense in our brain. But then when we mix it all together, there's a lot of different rules, and we've got to get them all straight. So this is good because we get to kind of have all the different um, types of exponents and the ways we solve them all together on one page and work them out. So number 1, basically it says which shows the expression a times a times a, b plus 3 times b plus 3 using exponents. So if we wanted to write this as exponents, we've got a repeating a times itself 3 times. And then we've also got this b plus 3 in parentheses times itself twice. And so if we look down here, it looks like we've got a to the 3rd power, which is a times a times a, and then b plus 3 to the 2nd power, which is what's described up here. So I think the answer here would be C. Evaluate 2x squared if x equals 3. So let's write this all out. X is 3, and that's squared. So remember, when we are working with exponents, PEMDAS says parentheses, then exponents, which means your exponent is always what you're going to work out first before you multiply or divide or add or subtract. And we've talked about how the power, the exponent, goes to the base directly in front of it, unless everything was in a parentheses. Therefore, when we multiply this out, we've got 2 times 3 squared, which is 9. And so we're not going to multiply 2 times 3 first. We're going to wait until we do the exponent, power that, and then multiply by 2. So the answer here is G. So be careful with your basically order of operations here is what they're looking for you to make sure you know what order you actually work out a problem. Number 3, the prime factorization. So anytime you see the word prime, that means your answer should be made out of numbers that are prime numbers. So if you look at your answers, we've got 21, we've got 4 here. These are not primes because you could break those down even more. So immediately you know that A and C are not possible answers. But I would say, please work this out using the factor tree. You will be tested over the factor tree on your real test, and so there will be a space for you to do that. So I know that 84, I think I could break that down to maybe 4 and 21. Okay, so even though, 4 and 21 match what C says, these are not prime, so I need to break these down some more. This is 2 times 2. 21 becomes 3 times 7. Excuse me. And so these are all prime numbers, which I have 2 times 2 times 3 times 7. So I'm going to circle. I like circling the prime numbers to tell me that as I'm doing the factor tree, I am done. I don't need to break those down anymore. So my answer is D. Okay, choose the number that is prime. So right here, we've kind of got to think through, are there any, can these numbers be broken down into numbers, factors beyond 1 in itself? And if it can, it's not a prime number. It's called a composite number. So 21's not because 3 and 7, right? 37, I'm not sure, so I'm going to skip that one. 49 can be broken down to 7 times 7. 55 can be broken down to 5 times 11. So if I were to guess, even though not sure, I'm like, okay, can other numbers be broken down in 37? Well, all the other ones can be broken down. So I'm going to say G is my answer. Okay, number 5, find the product. So we are going to take a look at what we have here. We have G to the 6th power times 8 times G to the 2nd power. Now, all this is in parentheses. However, this squared is just with the g. So let me just expand this out first. I've got g times g to the 6th power times 8 times g to the 2nd power. And so if I really expanded everything out, I'd have g times itself 6 times here, and then I'd have g times itself 2 times here. And remember, when we're multiplying exponents with the same base, we can just add them. So 6 plus 2 is 8. And 8 times, there's no other number for 8 to multiply it by. So I'm going to leave 8 as it is. And then g becomes to the 8th power. Okay. And so B is your answer. What has the same value as p to the negative third? Well, remember, a negative power is really just written as 1 over that same base to that same power, but positive. So H is our answer. Okay, now short answers, kind of writing this out on our own. Write this as an exponent, so 3 times itself 3 times, and then 2 times itself 2 times. And so that's as simple as that. Write the prime factorization of 36. I'm going to use the factor tree. 6 times 6 is 36. And then I have 2 times 3 and 2 times 3. So I'm going to write this as 2 times 2 times 3 times 3. If you wrote it as 2 to the 2nd power, 3 to the 2nd power, I wouldn't count you wrong. But it's asking you to just write it as prime factorization. So just expand everything out and don't worry about your exponents here. Okay, factor this out completely. So this would become 6 times 11, and 6 can be broken down to 2 and 3. So this would be 2 times 3 times 11. And then this one, factoring it out completely, 24 can be broken down to 4 and 4 times 6. This would be 2 and 2, and then this would be 2 and 3. So this is going to be long, but I have 2 times 2 times 2 times 3 times x times x times x times y times y. Okay, long one, but I have to also expand out my factors of the powers here. Okay, find the product or the quotient. So here I've got a coefficient of -2 and 7. I can multiply those. So if I just broke everything down, actually, I'm going to just rearrange this a little bit. I could write this because when I multiply, I don't have to, I could change the order if everything's being multiplied. So I could write this as -2 times 7 times d to the 2nd power times d to the 9th power. And then -2 times 7 is -14. And d to the 2nd times d to the 9th is just add those exponents. And that would be d to the 11th. And that's my answer there. Okay, when we're dividing, remember we can expand it all out. And then whatever is, top and bottom that's alike, we can cancel. So I'm not going to expand out, n to the 10th power or n to the 6th power. That's a lot. But the rule here is really I can subtract them. And so 10 minus 6 is 4. So this would just be n to the 4th power. And then writing this as an exponent using a negative exponent other than 1. So what they're saying is do not write this as 49 to the -1st power. Let's figure out how to power this out. So if I were to break down 49, I could write that as 7 to the 2nd power, right? And so 7 to the 2nd power as a negative exponent is 7 to the -2nd power. So that is my answer there. Okay, so one more thing we're going to look at are basically scientific notation and multiplying monomials, products of monomials. So I'm just going to briefly go over scientific notation down here. So if I have 3.4 times 10 to the -4th power, how would you write this out as an expanded, actually not expanded form, the standard form? How would you write this as a standard form? So I'm going to give you a second to do that. And then I'm going to give you another problem down here. 1.705 times 10 to the 5th power. Okay, so notice I have a negative power and a positive power. So looking at this, I'm going to use my little trick with my decimal. Starting here, I'm going to go 4 to the left. 1, 2, 3, 1, 2, 3, 4. So if you're confused with counting out your decimals, count this little bump, okay? That's where you're filling in your numbers, okay? And then where it ends, you're going to put your decimal there, 0, 0, 0. So you're moving it 1, 2, 3, 4, 4 times to the left, and it's 0.00034. Now writing this as a standard form, multiplying it to the 5th power. So I'm going to move my decimal 1, 2, 3, 4, 5 to the right, fill in my zeros, and that is my answer, and it's 170,500. Okay, let's do the reverse where I give you a number and you write it as scientific notation. So 379, write that as scientific notation, and then 26,880, write that as scientific notation. Now be careful with scientific notation. Remember the rule is that your number that's being multiplied by 10 to a power has to be between 1 and 10. So this is 3.4. It's written as a number between 1 and 10. You've got to put your decimal in a place that makes your number between 1 and 10. So if you're looking at this, we have to think about where are we putting our decimal to make this a number between 1 and 10. It's going to go right there. This one down here, where are we going to put our number to make this between 1 and 10? It's going to go right here, right? So now we can multiply by 10 to a power. Now make sure you write it as multiplying by 10 to a power. Don't just write it as that to, this number to a power, because that's saying something totally different. So make sure you write this part out. Okay, so we need to think through. Well, if I wanted to make this back to the standard form, I have to move my decimal 1, 2. So I'm going to move this, multiply it to the 2nd power. Okay, this one, I have to move my decimal 1, 2, 3, 4. So this would be 10 to the 4th power. And it's as simple as that. Okay, our last few problems. Let me remove some of these problems so I can have some space to write these last two, where we're multiplying out monomials, where there's factor, or there is okay, I'm gonna just erase all this. Okay, so our last one we're going to take a look at is multiply monomials, meaning you've got a power, basically like a power to a power. Okay, so we've talked about this, where I like looking at this little parentheses as a little trick thing for me, where if I connect these exponents, it looks like a multiplication sign. So that reminds me of the rule. The rule is that I can multiply. So 6 times 3 is 18. So this would be 2 to the 18th power. When in doubt, expand it out, right? Make this 6 times or 2 times itself 6 times, and then that times itself 3 times. So you've got like 6 2s times 3 times, so that would be 18 2s. Okay, this one has a little more going on. We've got your term inside your parentheses and your exponent outside. Now remember, when there's a product inside your parentheses, you've got to distribute your exponent. So basically we're looking at this as -2 to the 6th power times n to the 4th to the 6th power. Okay, so I might have to get my calculator out, but -2 to the 6th power, when I actually work this out, is 64. So positive 64. And then 4 times 6 is 24. So it's n to the 24th power. Okay, last one. 5w to the 5th power, x to the 8th, and all this to the 3rd. So remember, we have to distribute this into every term. And so I have 5 to the 3rd times w. I'm just going to multiply it. So 5 times 3 is 15, and x to the 24th. And now I need to actually expand this out, or not expand it out, but work it out. And so 5 times 5 times 5, I can plug that in my calculator. It's 125. And this is my answer right here. There you go. Okay, so hopefully this was helpful. But if you have any questions, don't hesitate to ask me. But that's all I have for you guys.